Hello students, welcome to MJC Learning. I am Manju Dilip. Today I am going to start with the 12th standard mathematics chapter Differentiation Part 6. We already studied in the previous video about inverse trigonometry functions. So today again we are doing the same, and one more topic we are doing today, logarithmic differentiation. So I'll start with the question. First question is cos inverse of 1 minus x square upon 1 plus x square. In this type of question, you have to give substitution for x. So, you already studied this kind of substitution in 11th standard. Um, then here we have to substitute tan theta in the place of x. So, when you are substituting 1 minus tan square theta upon 1 plus tan square theta, while substituting, you have to check the outside term is cos inverse. So you must get, after substituting, you must get the term which is related to cos or sine. Then only it will cancel. For that, we are giving substitution at y equal to cos inverse of 1 minus x square upon 1 plus x square. Put x is equal to tan theta. Therefore, theta is equal to tan inverse x. We are finding this for future use. So, putting it as equation number 1. The question will become y is equal to cos inverse of 1 minus, in the place of x we are giving tan theta. So, tan square theta upon 1 plus tan square theta. And we know this formula 1 minus tan square theta upon 1 plus tan square theta is equal to cos 2 theta. So, we are giving inside this bracket term, that means 1 minus tan square theta upon 1 plus tan square theta is changing with the term cos 2 theta. Now cos inverse and cos both will cancel. So in the next step you will get 2 theta. And you have to give, in the place of theta, you have to resubstitute before differentiation. Till now we are not differentiation done. So we have to take the value theta is equal to tan inverse x, that we will substitute in the place. So this term will become y is equal to 2 tan inverse x from equation number 1. Differentiating with respect to x, you will get dy upon dx is equal to 2 is a constant, 2 as it is. Then what is the derivative of tan inverse x? It is 1 upon 1 plus x square. So we are substituting 1 upon 1 plus x square in the place of tan inverse x. So the final answer for this question is 2 upon 1 plus x square. Next question is cos inverse 3x minus 4x cube. Here again you have to give substitution like that way. We know that this is similar to 3 sine theta minus 4 sine cube theta. That is the formula for sine 3 theta. So we can give that substitution. So let y is equal to the given question. Put x equal to sine theta. Therefore theta is equal to sine inverse x. Then this term is equal to cos inverse of 3 sine theta minus 4 sine cube theta. We know this formula, 3 sine theta minus 4 sine cube theta is equal to sine 3 theta. We are substituting this inside the bracket term. So now this term is sine theta inside and outside is cos inverse. If it will come cos, then only it will cancel. For that we can use allied angle formula. So cos of pi by 2 minus theta is cos 90 minus theta. Cos 90 minus theta is sine theta. So sine 3 theta. So cos inverse and cos will cancel in the next step. So you will get pi by 2 minus 3 theta. Now you have to resubstitute in the place of theta as 3 into sine inverse x. From equation number 1 we are getting like this. So y is equal to pi by 2 minus 3 sine inverse x. Now we'll take derivative. So differentiating with respect to x, you will get pi by 2 will become 0. Minus 3 into sine inverse x derivative is 1 upon root of 1 minus x square. So minus 3 upon root of 1 minus x square is the final answer for this question. Next question is sine inverse of 4 raised to x plus 1 upon 2 upon 1 plus 2 raised to 4x. In this question you have to check it properly. Here inside the bracket term is 4 raised to x plus half upon 1 plus 2 raised to 4x. So here you can make this 2 raised to 4 as 4 raised to 2x. So 4 raised to 2x. So we'll start with this question. So as it is, you will write the first, let y is equal to this question. Sine inverse of this, you can use the indices property a raised to m into a raised to n is equal to a raised to m plus n. So you can split it like this upon 1 plus 2 raised to 4 can be written as 4 raised to 2 into x. Now 4 raised to x you can take like this. So a raised to m into n is equal to a raised to mn property we are applying here. So this will become like this. Now in the next step you can take root 4 as 4 raised to 1 upon 2 can be written as 4 root 4. Root 4 will become 2 in the next step. So 2 into 4 raised to x upon 1 plus 4 raised to x whole square. Now if we are giving substitution for 4 raised to x, then you have to get sine inverse. So that means sine term you have to get after substitution. So 4 raised to x you can give tan theta. So 4 raised to x is equal to tan theta, theta is equal to tan inverse 4x. Now this term will become 2 into tan theta upon 1 plus tan theta whole square. That will become sine inverse of 2 tan theta upon 1 plus tan square theta. Now inside this term is sine 2 theta formula in terms of tan. So sine inverse of sine 2 theta, sine and sine inverse cancel. So 2 theta. Now we'll resubstitute in the place of theta it is tan inverse of 4x. Now we can take derivative with respect to x. Differentiating with respect to x, you will get dy upon dx is equal to 2 into derivative of tan inverse x is 1 upon 1 plus x square. So 1 upon 1 plus in the place of x it is 4 raised to x whole square into you have to take the derivative 4 raised to x. This is function of function, composite function derivative. So 4 raised to x is in the format of a raised to x. Derivative a raised to x is a raised to log a. So 4 raised to x into log 4. This is the final answer for this question. Next question is cot inverse of 1 plus 35x square upon 2x. Here you have to change this term in form of a plus b upon a into b like that. For that we are just splitting this 35 into 7 into 5. You can factors of 35 must be satisfy this condition. So 5x into 7x will give 35x square and 7x minus 5x is 2x. So we can change this term as 1 plus 7x into 5x upon 7x minus 5x. Tan inverse, next term we know this formula cot inverse of x is equal to 1 upon tan inverse of x. So we are utilizing that reciprocal formula. So tan inverse of 7x numerator will become denominator and denominator will become this one. So tan inverse of 7x minus 5x upon 1 plus 7x into 5x. Now we know this formula tan inverse of a minus tan inverse of b is equal to tan inverse of a minus b upon 1 plus a into b. So this function will become tan inverse of 7x minus tan inverse of 5x. Now we can take derivative with respect to x. So dy upon dx is equal to derivative of 7x is 1 upon 1 plus 7x whole square and the derivative of 7x is 7 minus 1 upon 1 plus 5x whole square into 5. In the next step you can write this as 7 upon 1 plus 49x square minus 5 upon 1 plus 25x square. This is the final answer for this question. Next question is cot inverse of a square minus 6x square upon 5ax. Here again you have to split that some adjustment you have to do. So first step itself we are taking the reciprocal function tan inverse of 5ax upon a square minus 6x square. Now we have to make this term in addition format, then denominator 1 minus into product format like that. You have to change it. For that 1 minus format you need. So a square is extra here, so you will divide both the numerator and denominator with a square like this. So tan inverse of 5ax upon a square upon 1 minus 1 a square upon a square will become 1 minus 6x square upon a square. Now this term numerator can be split into 3x upon a plus 2x upon a. Here a and one of the a cancel. So 5x upon a is the remaining term. From that 3x upon a plus 2x upon a. And denominator, if you are multiplying these two terms, you must get 6 square. So 2 3s are 6, x square upon a square. So you can write this term as a product form. So 1 minus 3x upon a into 2x upon a. This is the formula. Tan inverse a plus tan inverse b is equal to tan inverse a plus b upon 1 minus a into b. So we can split this term tan inverse of 3x upon a plus tan inverse of 2x upon a. Now differentiating with respect to x, you will get 1 upon 1 plus 3x upon a whole square, that is 9x square upon a square, into derivative of 3x upon a is 3 upon a, minus derivative of tan inverse 2x upon a is 1 upon 1 plus 4x square upon a square, into derivative of this is 2 upon a. So dy upon dx is equal to this one. So it will become one of the a and a cancelled. Here again it is cancelled. So 3a upon a square plus 9x square minus 2a upon a square plus 4x square is the final answer for this question. Next question is tan inverse of a plus b tan x upon b minus a tan x. So we will divide the first term a plus b tan x. So numerator will divide with b. So a upon b plus tan x upon 1 minus a upon b into tan x. This is tan inverse of a upon b plus tan inverse of tan a formula. Same formula we are applying here. So tan inverse of a upon b plus tan inverse of tan x is x. So in the next step, differentiating with respect to x, you will get the first term as 0 and derivative of x is 1. Next question, next is logarithmic differentiation. In logarithmic differentiation, the function of function format, it will come. So function f of x raised to g of x. So you can take log on both sides. So log y is equal to g of x into log of f of x. This is called logarithmic differentiation. Law of exponential we applied here. So I will solve one question. Differentiating with respect to x, x plus 1 whole square upon x plus 2 whole cube into x plus 3 whole raised to 4. Three algebraic functions are given. So let y is equal to the given question. Taking logarithm on both sides, log y is equal to log of this whole function will come like this. So now this is log a upon bc format. So you can use laws of logarithm. So log y is equal to log a minus log b plus log c. Law of product we have applied here. So log y is equal to 2 into log x plus 1 minus 3 into log x plus 2 minus 4 into log x plus 3. Law of exponential applied. Differential with respect to x. 1 here it is log y, it is not log x, so you have to take derivative of y. So 1 upon y, and you have to take derivative with respect to x, that is why dy upon dx is equal to 2 into log derivative of log x plus 1 is 1 upon x plus 1 minus 3 into 1 upon x plus 2 minus 4 into derivative log x plus 3 is 1 upon x plus 3. Now we have to find dy upon dx. So we have to cross multiply this y. In logarithmic differentiation, the given question will come in the final answer. Resubstituting the value in terms of x, you have to get the answer in right hand side. So resubstituting the value of y, that is this one, you will get like this. So in logarithmic differentiation, the full question will come in the place of y. This is the final answer for this question. Some exercise questions are given to you. You have to solve it. Thank you.